Okay, welcome to COP 2220. Today we're going to review about loops. So let's get started. So we're going to talk about loops in the language C. All right, so in the language C and for this course, there are three kinds of loops. We have for loops, while loops, and do while loops. And when you're dealing with for loops and while loops, there are three things that you need to make sure that you check when you're developing your loops. One is you need to make sure after you design your loop that in order to control it, you initialize your loop controller. The second thing is there's the test part of the loop, and the third thing is the update part of the loop. Now, most of the time, you also need to initialize, test, and update when you're dealing with do-while loops, but for sure, with do-while loops, you're going to need to test and update. Now, the one thing about the do-while loop is that the do-while loop will test after the loop body. And that's very important to keep in mind because what that means is that the do-while loop will always do whatever it is that's happening one time and then test at the end. Where the structure of a for loop and a while loop, both of them test at the beginning. So I will demonstrate that in a minute and the difference about that. All right, so all loops are set up with a block of code, just like everything else in the language C. So a for loop is going to have a header and an opening curly brace and a closing curly brace. And a while loop is going to be set up the same way, with an opening curly brace and a closing curly brace. Now the difference between a for loop and a while loop is that a for loop, in the header of the for loop, you have your initialization and your test and your update are all inside of the for loop header. Where in a while loop, you have your initialization before the test then you have the test in here, and then you have the update step somewhere inside of the while loop. So let's just do a quick example. I'm going to pick a different color to put inside here. Let's use white. All right, so I'm going to do a quick example of a counting loop that's going to print 10 numbers onto the first numbers 1 through 10 onto the screen. So you start with an iterator. So we're going to have to declare our iterator, which would be int I. And in the for loop, if we want our loop to go 10 times, we would start, I'm going to start from 1 and go up to 10. We would say for I less than or equal to 10, and I is going to start at 1, and it's going to go up by 1 every time. So this is our initialization, I equals 1. This is our test, I less than or equal to 10, and this is our update, I plus plus. And then what we're going to do is we're going to print I is %d, and we're just going to print the value of I onto the screen. Now in a while loop, we're going to need to declare our variable. So we will declare our int I here. And again, this is not a complete program. This is just showing you, going over again what we already did in class about loops. So this is not even meant to be teaching you everything, it's just review. So we have our variable I. So here with the while loop, we would initialize it before the loop, I equals 1. Then the test condition is going to go inside of the loop header, I less than or equal to 10. And then the update is going to go inside of the loop body. So we're going to update I plus plus. Now just as a refresher, I plus plus can also be written as I equals I plus 1, which can also be written as I plus equals 1. So these are three different ways to do the same thing. You can only use the plus plus if you want to go up by 1, and only use or minus minus if you want to go down by 1. But you can use this or this for multiplication, for going up by 5, going down by 10, for all different. If you want to just go use the plus plus, they can only be used if you're going to go up by 1, or minus minus if you're going to go down by 1. All right, so what are we missing here? We're just missing our print that we would print onto the screen. And I ran out of room, but my semicolon is at the end, and those quotations, of course, are after the comma, but I ran out of room. So this is just an example of a counting loop, a loop that will go 10 times. And in this case, it will start at 1 and go up to the number 10. So now I can show you the one that we did in class, the example that we did in class. And the example that we did in class was that we printed the first, we calculated the sum of the first 11 the first odd numbers up to 11. So we started from 1 and we went up to number 11 and we calculated the sum and the product. So I will do that with a for loop. So we start out, we have to have a variable sum, which we will initialize to 0, a variable product, which we will initialize to 1, and our iterator, I, which we're going to initialize in our for loop. And our for loop will be for I equals 1, because we're going to go start from 1, go up to 11, I less than or equal to 11. But then instead of going up by 1 every time, we're going to go up by 2 because we care about the odd numbers. So we're going to do I plus equals 2. And then inside here, we're going to calculate our sum. Sum plus equals I. We're going to calculate our product. Product times equals I. And again, we could print the I onto the screen, but I'm running out of space. So let's just do a couple of test cases to see if this is working properly. So we will start out when sum is 0 and product is 1. So the way that you read the loop, for loops, it always does the initialization first one time and then it tests. So we're going to start for I equals 1, I less than or equal to 11. And if this test is true, you will go inside of the curly braces and inside of the loop body. So I is 1. Is 1 less than or equal to 11? Yes, it is. So it's going to go inside of the loop body. So it's going to take the current sum. So I is 1 here. And it's going to take the current sum, which is 0, and add 1 to it. So sum is going to now change to 1. Then it's going to take the current product, which is 1, and multiply that times 1. So the product is going to change to 1. Then after it does everything in the loop body and hits the ending curly brace, it will come up here and do the update step. The update step is going to take whatever value I is and add 2 to it, so I will change now to 3. So now it's going to test, is 3 less than or equal to 11? Yes, it is. So it'll take the current sum, which was 1, add 3 to it, and sum will now change to 4. It'll take the current product, which is 1, and multiply 3 times it, and the product will now change to 3. Then it will do the update step. It'll take what I is, which is 3, add 2 to it, will then make it 5, and then it'll test, is 5 less than or equal to 11? Yes, it is. So then it will proceed to calculate the sum, which is, it'll take the current sum, which is 4. Keep in mind that this is the same thing as sum equals sum plus I. And this is the same thing as prod equals prod times I. So sum is currently 4, so it'll take the 4, then it will add the 5, which is I, and it'll change the value of sum to 9. It'll take the current product, which is 3, multiply times I, which is 5, and change that product to 15. Now if you want to, you can put printf in here so you can watch each step. You could print F. I is %D, sum is %D, and product is %D. I, sum, and product. Now you could print these. If you print them inside of the loop body, each time that the loop iterates, it's going to print the values for you onto the screen so you can follow, just like I'm doing over here, what's going on. Otherwise, if you want to know the results, you just print the results at the end. So I'm going to go up here and show you. I have the code in here. This is the same code that I just put. These dashes right here are just for printing onto the screen. They do not have any point. Just to, when you take the code that I put on Blackboard for you, you can you'll see how it prints onto the screen. The other thing I wanted to point out here is that in the example that I just showed you, I printed the sum and the product and I within the loop, and in the code I just printed the I in the loop, and then after the code runs, I printed the sum and the product at the end. Okay, so oops. Now we can go back and do the same thing with a while loop. So we have our integer, that should be an integer, sum equals 0, product equals 1. Our integer I, now since this is a while loop, we're going to have to initialize our I before the loop starts. So we have I equals 0. Then we have while I is less than or equal to 11. That was our test condition. And what we're going to do here is we're going to calculate the sum and calculate the product and update I. Okay, one thing I wanted to point out, when you are doing your loops, you can decide how you want to do your initialization, your test, and your update. Now in the for loop, by the way it's designed, the initialization, the test, and the update are all in the header of the for loop. So you can't really change the way you do things. And let's just take a look again. This is doing the exact same thing. Here's the initialization. Here, this is the, let's change the color here. Okay, so this is the initialization, this is the test, and this is the update. Now what I could do, if I wanted to, I could change the way, the order in which I do my update, or I could update here. I could do I plus equals 2 here. Now this would not be the best thing to do in this case, because what would happen is it would start at 1, it would test and say, is 1 less than or equal to 11? Yes, it is, but then it would immediately change it to a 3. So this would not be the best idea because it would miss, and maybe it would modify what my results are. But I just wanted to show you that when you do have a while loop, you do have the freedom to move your update. The other thing that happens with while loops is that students tend to sometimes forget to put the update step in here. And if you forget to put the update step, then what will end up happening is we'll end up with an infinite loop. So you don't really want that to happen. Now I'm going to make a different video with a do while loop because this is not the best. This kind of counting loop, it's better to use a while loop or a for loop. So I will do a different example in another video with a do while loop. But I did put the example in the code. So I have the example here with the for loop, and this is all on Blackboard for you. I have an example here with the while loop, and I have the same example also on Blackboard of the do while loop. So you can take a look at this code and see how it's done with a do while loop, a for loop, and a while loop. For loop, while loop, do while loop. All right, so there's one more example I'm going to do, and this is a different kind of loop. That loop was a counting loop. That's a loop that runs a certain number of times. This I'm going to do and write out for you. This is a loop where we're going to calculate the product and the sum, but instead of calculating the product and the sum by knowing in advance how many times it's going to run, we're going to have the user continue to enter a number until that user enters a 0 or a negative number to stop. So let's repeat what this is. What we're going to do is we're going to continue to have the user enter a number, and as long as they enter a number that is greater than 0, meaning they enter any number 1 and higher, we will continue to calculate a product with that number, and we will continue to calculate a sum with that number. And if they enter a 0 or any number below 0, we will stop the calculation, and this is called a Sentinel controlled loop. So we have our three things. We have to do initialization, and we have to test, and we have to update. So I'm going to choose to use a while loop to do this. So we have our variables. We're going to be calculating a sum and initializing it to 0. We're going to be calculating a product and initializing it to 1. And then we have our variable, which is a variable called num, and that one's going to have to be initialized. So how are we going to initialize it? We're going to initialize it with user input. So to initialize with user input, we would do scanf %d into our variable. And that's very nice, but every time that you scan in from the user, you also should prompt ahead of time. So we would say printf, enter a num. Now if the user enters a num that is greater than 1, we will add it to our product and our sum, and greater than or equal to 1. So our test is going to be while num is greater than or equal to 1. The same test could be, and it would be the same thing again, as long as it's the right test. You could have said while num is greater than 0. So if you think about it for a minute, num greater than 0, because we're dealing with whole numbers and integers, starts with the number 1. So you could either have while num is greater than 0, or you could do while num is greater than or equal to 1. Again, it doesn't matter as long as it works. You can use either one. Then inside of our loop body, we're going to calculate our sum. So we would have sum plus equals num. And we're going to calculate our product. Product times equals num. And then again, our update is going to be by user input. And of course, we're going to need to prompt the user. Now you can see by the way that this is set up, a while loop is a much better choice for this kind of loop. When you're developing your loops, you just have to make a plan. You have to decide, what is it that I'm trying to do with this loop? How am I going to control what's happening in this loop? How am I going to initialize what controls that? What is my test condition? And how am I going to update it so eventually, at some point, the loop may end and I will not have an infinite loop? So I always like to come up with my test condition first, because that usually helps me to create the rest of the loop. But it's also, when you're using a while loop, it's very common to forget the update step. So I'm just going to move here to the code because it's much easier to read. And you can see here that we initialize and my prompt is a little better here, a negative number or 0 to stop, I scan in the num, then I test. So if the user were to enter a negative number or a 0, it will never go in there because it will never pass this test. So if this test is not true, it does not go inside the loop body. It just goes to the ending curly brace of the loop, which is down here, and finishes there. It will, if the test is not true, just like with conditions, it will not go inside the body of code. So I hope this helps you to remember what we discussed in class, and you will be able to develop some loops. I will make another video doing some examples, some other loop examples and a do while loop example.